we have just seen the nitro group as an example of an electron withdrawing group by resonance. But not only the nitro group can behave as an electron withdrawing group by resonance. Basically, any group that has a multiple bond between the atom that's directly attached to the benzene ring and another heteroatom such as nitrogen or oxygen. Let's take carbonyl compounds. So if you take this general structure for phenyl ketones, if you're careful at the structure, you would notice that there's a carbon-oxygen double bond. Recall the nitro group. There was a nitrogen-oxygen double bond, and you can see the connection now. Okay, if you break this carbon-carbon double bond to make a double bond here, like this, you would break this carbon-oxygen double bond, and obviously that's because oxygen is an electronegative atom. Now, this will give us another resonance form as a result of this withdrawal of electrons. Now, we could see that that carbon, as a result, carries a positive charge. So there is therefore resonance withdrawal in this phenyl ketone. That's because such compounds have a carbon-oxygen double bond. Oxygen is more electronegative than carbon. So that's like the driving force behind this resonance withdrawal, or behind withdrawal of electrons by the electronegative atom, that is oxygen. You can continue to delocalize electrons in the same manner that we did before. So we break that carbon-carbon double bond, and now we make a double bond here between this carbon and the positively charged carbon to get something like this. And now, in this resonance form, the positive charge is on that carbon. You can continue to get another resonance form by breaking that carbon-carbon double bond, and now making a double bond between that carbon and the positively charged carbon on this form. If we do that, we get an additional one. So that form, or that resonance form, is therefore obtained, that form that has a positive charge on this carbon. So this is an example, therefore, of another electron withdrawing group by resonance. So ketones or carbonyl groups are electron withdrawing groups by resonance. We have also to mention that oxygen is being more electronegative. It withdraws electrons toward itself in this carbon-oxygen double bond. So therefore, there is also remote inductive withdrawal, but that reinforces the resonance withdrawal of electrons by the carbonyl group. Let's now take another example in order to illustrate this electron withdrawal ability by resonance, by taking this time cyanobenzene. So this is the cyano group. In the cyano group, there's a triple bond between carbon and nitrogen, but this is also a strong electron withdrawing group by resonance. So how does it do that? Well, we do exactly what we did before. So you break that carbon-carbon double bond, you make a double bond here, and as a result, one of these pi bonds is broken. If we do that, then we get something like this. and as a result, that carbon has lost its electron share, and therefore it must carry a positive charge. You can continue with writing more resonance forms in the same manner that we did before. So the cyanic group is also an electron withdrawing group by resonance. Okay, so what's required therefore is basically a multiple bond, whether it's double or triple, between the first atom that's directly attached to the benzene ring and another atom, and the other atom must be a heteroatom. It must be more electronegative than the atom that's attached directly to the benzene ring. In this case, nitrogen obviously is more electronegative than carbon. In this carbon nitrogen triple bond, oxygen is more electronegative than carbon. So there is a carbon-oxygen double bond, a carbon heteroatom double bond. There is a carbon heteroatom triple bond. In the nitro group, there was a nitrogen-oxygen double bond, a nitrogen, another heteroatom double bond. The other heteroatom is more electronegative than nitrogen. So in all of these cases, resonance withdrawal is possible. Not only in nitrobenzene and in phenyl ketones or benzene rings with an acyl group or a carbonyl group, or in cyanobenzene, basically any benzene ring that has a double bond between the atom that's directly attached to the benzene and another atom. You take, for example, benzene sulfonic acid, just like an additional one. So this is benzene sulfonic acid. So SO3H. So you can see that there is sulfur oxygen double bonds, and there are two of them. So that's enough. The presence of a multiple bond or this double bond between sulfur and oxygen entitles, if you like, this sulfonic unit to behave as an electron withdrawing group by resonance. So again, in summary of this, an electron withdrawing group by resonance must have a multiple bond between an atom and another atom which is more electronegative, for that heteroatom to be like the driving force behind the resonance withdrawal.